Hello everyone, a very good morning and a big thank you to everyone for coming on a beautiful Sunday morning and just make it very memorable day. So this is the first Indian AI Appreciation Day meetup organized by WebOccult Technologies and hosted by IT Path Solutions. My name is Hardik Sonchabda and I am working as a Chief Operating Officer at WebOccult Technologies. Okay, so this is the first AI and specifically computer vision centric meetup WebOccult is organizing. So we would first like to see what WebOccult is doing at its core in terms of providing these services. So here we have, we are working on AI ML, web development, mobile app development and development specifically. And if we talk about our venue partner, our hosting partner for today's event, IT Path Solutions, let's take a look at the services that they are providing. Microsoft Technologies, Enterprise Content Management, Custom App Development, Mobility Solutions, IoT, Blockchain Engineering, Enterprise E-Commerce, Extended Reality, and BI and Data Analytics. Okay. Am I audible to everyone? Yes. The people who are sitting at the back, are you all enjoying? If you want, you can come this side as well. Here we have a lot of space, and I would say tangy space as well.
So you are audible but not visible.
Yeah, that will be the problem. Otherwise, our YouTube live viewers will not be able to see anything. I would also like to welcome the live audience who are enjoying this session from YouTube as well. Thank you very much for joining. Okay, so let's start with today's main agenda. AI Appreciation Day. Anyone knows any history about this day? I'm sure like when this event was announced and when you have registered for this event, this would have got your interest, and I think you would have gone to Google and searched for this day at least once. So if anyone wants to share any of your thoughts, your ideas, then I would really appreciate this conversation. Anyone? Guys, let's make it a bit interactive, okay? Okay, કોઈને છે આઈડિયા? ગુજરાતીમાં એકવાર પૂછી લઉં છું. What is the history behind this day? Okay, let me tell you. There is a little story, small story behind this. We at WebOccult, since last 5 or 6 weeks, we have been constantly thinking about starting this kind of meetups. And we also planned that we'll start monthly meetup for computer vision subjects, and the planning was very much going strong. But one of our colleagues who was as a part of her day-to-day activities or work, she was searching for these famous days which were coming in this month, and somewhere she got stuck with this name, AI Appreciation Day. So we got an idea that as we want to start this kind of meetups, there cannot be any better day to start with. So we decided that we'll start our first official meetups by celebrating it on the 16th July, and luckily it fall on Sunday as well, so it was very good. Regarding the history, it is a little surprising. AI Heart Company, there is a company called AI Heart Company. I think it is in USA. They are hiding some of the things I have seen, but most probably they are in USA. They proclaimed this day with this organization, NDP, National Day Proclamation, and they decided that every year 16th July from 2021 will be celebrated as AI Appreciation Day. So maybe they would have done something in USA because both the companies belong to USA, but for India, for Gujarat, for Ahmedabad, we can officially declare that this is the first AI Appreciation Day being held in India. So a big round of applause for that. Okay, there has been a lot of debates related to AI. Whether it is good, whether it is bad, people are debating a lot. Over the years, we are hearing these things. We are still not sure that in the future whether it will bring good results or whether it will bring bad results to the community, to the people, to us. But as the agenda of today's day is to appreciate AI, we'll definitely appreciate AI. Artificial Intelligence Appreciation Day honors AI technology's positive contributions to humanity. It simultaneously highlights AI ethics and encourages a national conversation about AI and ethics. There are thousands of ways AI has been helping humanity. If we talk about ChatGPT, if we can make good use of it, it helps us in a lot of different ways. Google Translation, Google Maps, Gmail services for auto completion, auto correction, and other systems are also providing these facilities. Then AI assistants, then support in healthcare industry, travel industry, and where not, I would say. Like everyone is either using AI or they are trying to get into the zone where they can start benefiting AI. While searching for few things, I came across a very interesting thing that I would like to share. Any one of you have any idea like how many total number of AI powered devices are in use today in the world? Any number you can share. Total number of AI powered or AI instance assistant used products in the world. Any figure, any random figure?
Mostly on mobiles.
That is one of the examples. Okay, so mobile counts you all know. According to this research, by 2021 there were 4.2 billion devices with AI powered assistant. And to our surprise, by 2024 this will go beyond 8.4 billion devices. So this is the best way we can decide where the future is going and whether it will be a beneficial deal for everyone or not. Right? Before, sorry. Okay. Today we have got two brilliant AI geeks with us who have been serving in this industry since last 5+ years. Their name is Mr. Hiren Namera and Mr. Jaideep Bedadia. Big round of applause for them. Though they are going to present a session in such kind of meetup for the first time, but that doesn't mean that we'll take it anything lightly. We'll expect the best out of you guys in terms of the content that you are going to deliver, right? And before we start, I have a few requests to all of you. First of all, put your phone on silent mode if you have not done it till now. Second one is maintain silence while speakers are giving their speech, giving their presentation. Gather your questions and ask the speakers at the end of each session. Enjoy the meetup. ત્યાં પાછળથી લોકોને ન દેખાતું હોય તો ઊભા થઈ જાજો, બટ ટેબલ ઉપર ઊભા ન થતા, એટલું એન્જોય કરજો. And most importantly, increase your knowledge base. We have organized one small technical quiz in between two sessions as well. there are few questions which we'll expect everyone to answer, but even though you will not be able to answer, I'm sure you will get 10 new things out of those questions, right? And then at the end we have got some snacks arrangement, so we can make new friends, have chit chat with them, have snacks, and then we'll leave, right? Without wasting any time, I would like to invite our first speaker on the stage, Mr. Hiren Namera, who will be giving speech on power of generative AI. Let's welcome Hiren.
Hello all the AI geeks.
Hello.
I am Hiren Namera. I am working in WebOccult as a tech lead from last 5 years. So yeah. Before getting started, you may have heard lots of buzz about generative AI and what it is capable to do, right? If you open the LinkedIn or any social media, you will see lots of things about generative AIs. So today we are going to learn what is the power, how we can build generative AI from that. So yeah, first of all, what is the generative AI? So there are different fields of the deep learning, if you know. There is a computer vision, NLP, and all of those different fields. But this is the recently developed field of generative AI, where we can generate contents, text, audio, and images from the simple text or something like that. Before 2020 also there were some technologies like GAN and all of those available. But those were not able to generate good images or something like that from raw text or human texts only. So that's what we are going to do today, and what we are going to learn, like how it generates from that. So are you excited?
Yes.
Okay, let's get started. So the first thing, so here you can see 3 images. One of them is generated by AI and 2 of them are a photograph. So you have to guess like which one is that. So there is 5 seconds of time. 5, 4, 3, 2, 1. So raise hand who think like A is generated by AI. Okay. B is generated by AI. Okay. C is generated by AI. And I see some of you are little confused, like don't able to guess like which one is generated by AI, right? So let's see the correct answer. So yeah, the A is generated by AI, but it looks very real to us. So this is one another A. This is a little bit difficult from last one.
Would you mind shifting this side? Would you mind shifting this side? Please, up. Yeah, thank you.
Yeah. So here are 3 images. So 5, 4, 3, 2, 1. So who thinks A is generated by AI?
C.
B is generated by AI. Oh Lord. And C is generated by AI. So the correct answer is B. So you can see like AI is still generating some glitches, like repetitive, those mountains and those flowers are like repetitive. So that is still a glitch in AI. It is not able to generate all the things like very uniquely. So let's see like how these things are generated, right? Okay, so I need some prompt from your side. What do you want to see AI generate? So please raise hand.
Yes, anything you can speak, whatever you want this system to get generated for us. Anyone, please.
Anyone, yeah.
Sir, you, please.
You can, let's do one thing. Give us one word, right? We will complete it. Okay, so first word, anyone?
Moon.
Plan. Plan. Then second word?
Moon.
Dinosaur. Plan flying on dinosaur. Plan. Okay, plan flying on moon. Third.
Flower.
Flower.
Butterfly.
Okay, and butterfly and flower also. Let's see what it does. Refresh करना. Yes. Connection error net.
इंटरनेट છે
1101. Neeraj? No, phone picture.
क्या बेटर इंटरनेट ना
Okay, meanwhile they are setting these things. Can I know how many of you belong to AI? If you are working on anything in AI, I would just like to know. Yes, you. If you don't mind, can you just introduce yourself? You don't need to mention about the company, anything. Just what kind of things you are working on. Very quickly. Yes, sir. A bit loudly so your fans can listen to you.
I am CEO of Data Products. We are working on healthcare and renewable energy products.
Okay. Yes, other guys please who raise their hands who are working on AI technologies. Yes, sir.
Yeah, actually, I am working with AI from last 1 year and generating a content, generating an image, and generating different kind of videos and everything.
Okay.
So I have 1 year of experience to work with the AI.
So basically you are working on computer.
Yeah.
Anyone else? Yes, there, sir. Mike, please.
No, actually not doing much more, but I just generating a text for specific condition and with OpenAI DaVinci 3 template.
Great. Okay. Other guys, yes. Here.
Good morning everyone, myself Ashish, I am mobile application developer. As of now I am working on different products which leverage the generative AI or LLM or any kind of things. As of now I am working on social media which use likely minded people and how that algorithm works. Apart from that, I have worked in lot of platform integration specifically to machine learning and everything.
Good to know. Yes. Here, you.
Hello everyone, my name is Kiran Prajapati. I just started to learning the data scientist and AI and ML algorithm, that's all. And also use that type of how to generate the images from the text and other content.
Good. Thank you very much guys for sharing your thoughts and your introduction about this. One of the persons said that he wants to see dinosaur. Who was that? Okay, actually I am also interested in knowing that. Can you just spell dinosaur? DINOSURE. Please write. Okay, any other people? Anything is coming on your imagination? Yes.
Super fast running turtle having rubies on his back.
Okay, we will give you a separate chance. Anyone else?
Yeah, what do you want to do with this dinosaur?
Chandrayaan 3 successfully landed on the moon. It will just land in 40 days. Thank you very much. Yes, let's go with dinosaur first. It is, I think, the easiest one.
To place the dinosaur.
Dinosaur reading a book.
Okay.
Dinosaur reading a book.
Good.
That's really cool. Sir, I would like to take your idea. It was a bit lengthy, sir. Hello.
Yeah.
Yes, what did you say? Just speak a little slowly so
Yes.
my mate can write it.
A super fast running turtle having rubies on his back.
A super fast running turtle having rubies on his back. Its back.
Rupees.
RUBIES.
Yeah.
Rupees or rubies? Rubies. 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 Yes. Let's see what it generates. A super fast running turtle having rubies on its back. Yes.
And let's generate.
Input is correct.
Rupees.
How do
Instead of rubies, just a ruby.
how do we define a super fast running turtle? Let's do
Cinematic shot.
yes.
Add cinematic shot also. Super cinematic shot of a super fast.
It just does not provide us video, so we'll go with images only. Okay, the next definition, someone from here, Chandrayaan 3.
Yes. Okay, yeah, we can add the Chandrayaan 3 landing on.
Chandrayaan 3, I don't think so. It can.
Let's see if it is available in
Yes.
dictionary or not.
CHANDRAYAN landing on moon. That's brilliant, I would say. Anything else, guys? You want to try? Yes.
Actually, I want to generate some business banner images with a different language, like Italian or something else.
A business banner in Italia.
Yeah, this model won't be good for the text, but yeah, let's see.
Italian language.
Anyone here can read the Italy?
Does it make sense?
Yeah, right now.
Great. Yes, so this is the capabilities of AI, what it is doing. I would like Hiren to Hiren to explain about this system, what it does, how it is generating all these things. And yes, let's continue with the session.
So yeah, so, can I go back to the light So yeah, here you need to remember a few things. Hello. Hello. Yeah. So the first is the prompt. Second is the sampling. Other, if you don't remember, that is not a good. Yeah. So we can continue. Okay. Yes. So yeah, just remember this example. This will be very helpful for you throughout the. So there is a Batman eating pizza in a restaurant. Okay. So we can see like a generative generates these images in few seconds only, which may designer take hours of time to generate these images. Yeah, it is a bit complicated, but let's understand like what is overall high level idea about how it is generating. So let's get started. So the technology which we currently use it is Stable Diffusion. It is open source AI generative technology to generate images from the text, from human text or natural text which we can say. There are other technologies also like DALI, Midjourney, but those are not open source yet. This is the only technology which is currently open source and openly available for anyone to use. So we have added the prompt, that many think pizza in restaurant. We have given out input to the this prompt to the Stable Diffusion, and it given us a result like we seen with the dinosaur and those turtles and all of those things. So let's see what is inside the Stable Diffusion. So yeah, most of you know like think like a Stable Diffusion is only one model, but it is not a one model. It is combination of multiple models. So there are like 4 total models. One is like image encoder, or we can say autoencoder, VA, or whatever we say. Second is clip model, which is text encoder model. The third one is the base unit or scheduler model, and fourth one is image decoder. So what we do is like we give a prompt to our model Stable Diffusion. The prompt first goes to the image and text encoder, and it will generate 77 into 786 dimensional array. Now don't worry about it, we will learn about that. Then that array is provided to UNet. UNet runs for multiple steps. You had seen like 100 steps you added. So it will run for loop. And at each step it will generate some new information, it will add and remove some information. And based on that, after the 100 results, we will get one array of 4 into 64 into 64, which we provide to the image decoder. And image decoder converts that array into human visible image or picture, which we can easily identify. So now let's see how every one of the component is working. Okay, so first one is a clip model. In 2020s, you may have seen many models like if you provide image, it will give you the hashtag or it will give you the captions. Like most of the models are using for Instagram, you just need to provide the image and it will generate one text or a caption for you. So you don't have to write the caption and you don't have to find for hashtags. So that's the model, what it does. So it is trained on few images. Like if you go in the pixels or any open source data source, where you see the image and its captions also as a data set. So it does that, it detects that data. So yeah, there are in clip also, it is not a single model. There are 2 models responsible for generating clip. First one is the text encoder and second one is the image encoder. So encoder is like for image encoder, if you know about ResNet models or VGG models, so at the end what we get is like we get a sigmoid or softmax layer. Before that there is a linear layer. So if we remove that last part, softmax and sigmoid, we will get that linear output. And that linear output is called as embedding. Now that may be of any shape like a 512 to 128, 786, whatever you want to get, you can keep it. So that's the thing, and we can use it to match with other images. Like one images we can match with another. So that's how the Google algorithm of search image is also working. Like if you provide one image, it will match with other images. So it is not matching the content, it is matching that embedding only with all the images. And that operation is so fast. So let's see how it works. So yeah, now here you can see one flower or something like that, and below we found some similar images. Run another query. So yeah, there is one more flower. So it is having some diffusion with second one. It is matched with KNN. So it won't be that perfect. But if we use like cosine similarity is like negating each other. So if everything is same dimensional, then it will give us a score of 1. That it is totally matching. And if it is like a negating, then it will give us a score of 0 if it total opposite. Slide. And second one is text encoder. Yeah, open the text encoder is the same way as image. So each and every text have some dimension. Some people add like a boy, some people add gentleman, man. Those don't represent more different meaning. Man and gentleman, both will be almost similar to each other, right? So here you can see in 3-dimensional. So it will be in like a multiple dimensional, 786, something like that. But we have to narrow down it using the PCA, so human eye can visibly see it. So let's check any Okay, let's check amount. So if we see the amount is amount is matched with quantities, proportion, doses, quantity, fraction, portions, and all of those things. So, what do you think? Boy will match with what type of things?
Cowboy.
What is the similar to boy?
As a word or as a
Is the word only.
cowboy? Man.
Okay, let's see. So yeah, the boy's first closest match is girl. It don't make much sense, right? But why it's that? Because if we say hello boy, hello girl, so it is trained on that way. If other words are same and only one word is changing, that means both of them are having some similarity. But it changes in one way, like boy is a male and girl is a female. In that only dimension, both of them are changed. Else, anywhere you can use the same thing. You can see boys also. So boys is more different because we don't use like a plural and a singular in same sentence. We change some sentence portions. So that's how it is trained. Here you can see one more word, which is brother. So we may say, hey man, hey boy, hey brother. So that's why it is trained on same way, and all of them are having like a similarity with each other in that proportion. Back to PPT. Yeah. So how the training process of click part? We seen like how the embedding of image is generated, how the embedding of text is also generated, right? So when we start training our algorithm, we first add an image encoder and decoder and a text encoder. We first give both of them one image and similar caption. In first try, it is going to generate wrong answers always. We know. But after that, we get loss function of cosine. So what cosine does is like cosine decreases that loss. If I added a photo of boy and added a caption as a boy, so first time both of them won't match. But cosine similarity, we have to reduce it like from 1 to 0. Sorry, 0 to 1. So that's how we train it. And after some epochs, if we run it through multiple times, at the end what we see is like, okay, now the embeddings and text captions are matching with each other in cosine similarity. So yeah, let's take our Batman example. So first our text prompt is tokenized. Our computer won't understand our language, so we have to tokenize it. Like in this model, Batman is tokenized to 7223, but maybe our dataset don't contain Batman word. So what it will do is like it will separate Bat and Man in two separate entities, and then it will go one by one. Like instead of 5, there will be 6 tokens also. If our dataset don't have Batman in that. So once that is generated, for each text, we are going to get 1768 dimension embeddings. So anyone know like why there are 77? Because here are only 5 words. For one word, we are going to get 768. So that must be like 5 into 786, right? So anyone know like why it is 77? Okay. So other words like our stable diffusion can take maximum 77 tokens. If we don't provide other tokens, that's fine for it. It will take it as an empty space. So, but we have to add embedding to the layer because in our any model of machine learning, we have fixed size of input mostly and fixed size of output. So we have to keep that same way. Okay, you have heard lots about diffusion. So anyone know like what is diffusion? If anyone coming from like a science background, they must know what is diffusion process.
I think this is one question most of us can answer.
Here is the image also. So when we add a liquid like a color in our water, what happens is like it slowly dissolves. It won't just dissolve in one go, right? So that's the process, and that's what came in mind of our scientist Sang-Yeon. Yeah, the Song-Yeon is the creator or research scientist of this stable diffusion who created this. And first idea came in his mind, and his thought is like creating noise from data is easy, but creating data from noise is called generative AI, and that's what he created. Yeah. Okay, here you can see one Batman eating pizza event. We add some more noise. We can add noise in images, right? It is easy, or it is difficult. Yeah. So what we are doing is like we added some noise, then we added more noise, then we added more noise. Now many of you ask like why we are adding noise. We have to generate the image, right? We don't have to add noise or something like that. But that's the crazy idea about it. Like we are just adding some noise, so we can later in reverse process we can remove that noise which we had added. Because if we had added, then we know okay, we had added here. And our model okay, I need to remove this one. And if model won't remove that one, his loss function will get decreased. So he will try to boost up his gradient in his way, so he can remove more noise. So yeah. And this is how we create like our data set for a stable diffusion, where we had first we get little bit noise, then little bit more, little bit more, little bit. So here you can see 1, 2, 3, 4. So those are like levels of noise which is added in image. So at the end the image is full noisy. There is nothing. Yes. Okay. So what we give to our unit and cellular is like first we give the noisy image. You can't say anything in the noise, right? But it will generate from there. Then second we give noise amount, like how much noise amount is there, like 1, 2, 3, 4 in the scale. So here you have seen like we have added 100. So 100 is in cosine proportionality. So in first one it will get 100% noise. In last step you will add little bit noise only to get little bit variation. In each and every step we add noise to get some variation. If we don't add that noise, we don't get variation in all the go. We will get the same image all the time. So that's the thing which we don't want. We want like changing the image, or we don't need more diverse images. And third one is image embedding. બધાને સમજાઈ ગયું આ ન સમજાણું લાગતું નથી સમજાણું. Next slide. Okay, so here is what goes inside the unit. So the first one is our noisy image which we added to ResNet. So ResNet is trained to detect the noise. ResNet knows okay, this much is the noise. You need to remove that noise. So here given back the noise. Okay, this is the noise you have to remove. Then there is the attention. So what attention takes is attention takes one text input and says okay, these pixels are here. These are the good pixels. These are the bad pixels. I need to remove the bad pixel and I need to remove the good pixels with my image. What information I provided? If I provided turtle, I need to remove some pixels with the features of the turtle. If I provided the Batman, I need to add it with the Batman, and then we get our image. So yeah, here is the actual thing. So I had run the same image for like 10 steps, and I generated images after every layer to visualize like what happens undergo, like what is doing unit what is doing. So yeah, the first you see one ResNet. You see the noise over there. It is very noisy. Then ResNet had created multiple boxes. Anyone know like why there are multiple boxes over there, which ResNet had generated? Not exact, but our human eye can see three colors: R, G, and B. Our images are also contain R, G, and B. when we feed our neural network with RGB image only, what it does is like it creates more kernel of it. You may have heard about kernels and filters. So those are different filters of ResNet, which he had created itself to determine different details of the image. Because if there is only three colors, he is not too good powerful like our human to detect all the details. So he converts it into multiple filters at each and every layer. So we added the filters. Then we had given our prompt, attention, which is called Batman eating pizza in restaurant. We added that inside that grid of kernels. And what we are below is like attention map. So here you can see first 5 is only activated and other are same to same. Anyone know why that thing happened?
Token.
Yes, exactly. We have provided only 5 tokens. Others are empty spaces. So other are as it is. It is not doing anything in model. But the first 5, it is doing something. We don't know what is it. It is still like a blurry and it is adding some noises. So here is the after 5 step. That was the first step. So here we can see, okay, we have added one more noise to it, because at each level we are adding noise to get it improved images and we get diversified image. Here you can see little bit of Batman if you see, like here, very small, but it is visible. Over here, you can see the air of the Batman and restaurant and all of those things in different layers. But it is a very blurry still. So let's go to the next or last step. Okay. Here you can see something which looks like Batman or not. Here also you can see some noise which looks like something about Batman. Now you can see. So these are all the filters which are used to detect pizza, restaurant and Batman. So these 3 things have focused on this. So whatever you see in the like white color, it is activated, and whatever you see in the black, it is negative. We need to remove that. So once this thing is converted into this, but there is one problem about stable diffusion. Our images, we have generated 512 into 5 into 3, which is like a 7 lakhs into 86,000 something, which is very large to generate, and it contains lots of operations also. So if we do that into good compute also, like with multiple GPUs, then also it will take 4 to 5 days to generate that image. But we have we have generated in the small device also, right? So that's because of the VAE, variational autoencoder. So what it does is like it converts the whole image into small spatial image. It won't get like a full image into full image. Whatever image size it is, it will decreases the size by 8. So if it is decreased by size 8, then our processing will decrease by 2 raised to 8 power. So that is the power of a proportional over here, which follows the VAE. So that's why it is very fast. So VAE is like a training model. Once we have some image, we can compress it very low dimensional, and then we upscale it to our original image. Yeah, there will be some information loss in between, but it's okay because we want to generate images faster, right? In VAE, there are 2 types of things. First one is encoder which like decreases the size of the image, and second is the decoder which increases the size of the image. And there is between one kernel which is like a placeholder which we had used in our all the trainings. So here you can see the X is the actual image, then there will be encoder, and then there will be bottleneck, which is like a latent representation of the same image, which will be in some other dimension like 60 by 60 or something like that. So if we had passed 512 dimensional image, it is converted to 64 dimensions only in bottleneck, and all the processes which we have done, it is done on 64 dimension only. So it will be very fast than our 512 dimension to generate all the pixels in the pixel space. And at the end you see like x dash, it is not generated x, it is generated x dash. So x dash is similar to x, but it is not 100% at x. So here are few generated images. The first one you see, it is generated without VA. We have not used this VA for that, and we have used autoencoder only. So VA what does is like, rather than keeping just one dimension, it keeps its means and variances of the image. So from the, if we have like a means and variances of the image, we know a file can fly from this pixel to this pixel. That is better than having like a single stamp per image. Okay, this is the only image you have to generate. So that's the sampling method which we use. So here you can see like a different types of VAs trained on different purposes and their results. Okay, now we got the overall idea. Now the final thing. So this is the overall model. Now you will be better understand this, like how it worked. So first we passed Batman eating pizza in restaurant. So first process done is like a tokenized. We have converted this Batman eating pizza into some tokens, some numeric numbers. Then we have created it into embeddings, which is like a 77 cross 786. So we have got the text encoding. From there you can see 1 cross 4 into 64 into 64. We want to generate image of 512 only. But what we generated is like a noise is generated of 1 into 4 into 64 into 64. Because it is in latent space, we have compressed the image, and we see one more dimensional adding. Rather than if you see in RGB there is only 3 dimensions, right? But here is one more. So that is for variance and mean storage. Then we added the result to the unit. So unit has generated multiple images like those boxes, and then it is repeated multiple times, like 100 times or something like that, to generate our final image. And once the final image is generated, it will be also of size of 1 into 4 into 64 into 64. So we have to pass it to the VA to decode that and give us the image which human eye can see. So if I have given the image like those bounding boxes of Batman, you won't be able to recognize, right? It is a Batman or whatever it is or what color it is, and it is not a good image. So that's the thing VA has done. So yeah. Any question from your side? Yes?
Sir, where is the data set? Last में जो data set में आप
Which data set?
जो बेस में आया ना, वो कहाँ से आया? नहीं, last one.
Okay, this one.
Yes.
It is generated from VA. So you have seen those boxes, right? 20 boxes, 40 boxes of VA.
In a deep learning, we are first of all import some data set like Kaggle and CSV and some.
Okay, so you means like how we train that? Yes. Okay, so the first training process is Clip. So Clip we had trained like we have taken some images from Pexels. Pexels is license free. So if you want to train some images from there, we have taken that and we have created captions of it. So what end we got? We got one Clip model which can encode an image in the text. So here if you see every unit layer text embedding is going there. So what is happening, like there will be an image also and there will be one text also. So we see the cosine similarity. If the cosine similarity is more, then okay, our image is going in good way. If it is bad, then we need to remove all those pixels which are creating those bad embeddings. So that's how it's creating. And second model which we need to train is unit. So we take unit from like our hundreds of images we have taken, we have added noise in all of those layers. And we fitted it. And we train our unit to only this one thing, that is like remove the noise. Then we added our attention layer to our unit. So what attention layer is used? It like it checks all the text and it matches with them. Okay, and gets attention. If you see in that last image, like there are multiple images, only 5 of them are activated. Others are not activated. So all 5 of them are activating different features. So if first one is Batman, it is only enabling the Batman only. It don't care about other things. Batman eating. So eating is related to pizza and Batman also. So it activates both of those things. Like it activates Batman also and pizza also, and it checks both the things. So that's how we have created that attention layer. So once that is run for multiple times, we get noise every pop, so we can get some diversification or some changes which we need. And after iteration, like if after running 100 steps or something like that, what we got is we have one image which contains all of those features. And if we pass that feature image to VA, it will generate our final images.
Anyone else? Any questions?
Yes.
I want to know how you handle moderation. Like anyone pass any kind of prompt. Right?
Yes.
So how do you handle it and where is it handled?
Prompt is first handled in our embedding. So if you pass good prompt, like there is a prompt engineering field also there, we have added pass very low. The field which is passed in prompt is very low. We have to pass very specialized, like a cinematic source, Fuji camera, because it is trained in that way. If you see Pexels images, there is written, okay, it is captured by this photographer, this is captured by this photograph also. So we can add that variation. And if you want to increase the variation in our image generation, so you need to add more noise. So you can, there is one parameter for CFG. If you increase it, it will add more noise. So more noise means model have to remove more noise. And more noise means more diversification. If you scale like a our noise to 0, it won't add any noise. And at the end what you get is noise only. Because there is no extra noise is added. Or very bad image or not a good image. So that's the thing over here for moderations.
What is the maximum size of program?
Maximum?
Like there is a limit. Like
yes,
you
yes.
pass like 80,000 around token in ChatGPT, right?
Yes.
So what is the
for this model which we have used 1.5, it is having length of 77 tokenized. So it is roughly around like a 50 to 60 words.
Okay. Great.
Yes.
So why you are developing this tool? Because Midjourney already.
Yeah, we are not developing it, but we need to learn it. How we can, if we want to generate, how we can develop. Yeah, if I will give Midjourney, okay, give me logos of a WebOccult in every image. Like somewhere we must need image, not only like as a watermark or something like that. So will Midjourney give me that model?
You put already some images. Yes, in that part. So we create already.
Yes, that's the thing. If we want customization, yeah, there is Google also which is doing all the software stuff. But what we can do is we can add customization to anything. And the second thing is open source community. If we don't have open source community, then all
but
the
you are using third party, so it's click model.
Yeah, it is not third party. You can say it is open source. Open source.
Yes, it's open source third party model.
Yeah.
So yes, that's why.
Yeah, but we can train it. It is open source, so we can train it. We can add our layers. If I want to add my 2 layers at a time, I can add it. Right? But in Midjourney side, I don't have that freedom. I have to do what they can do. Like if I give WebOccult logo and give them, okay, give me some model, my trained only, which can generate WebOccult logo in each and every.
You arrange some file of this WebOccult logo and it's give some better output of.
Yes, it may give, it may not give. But that's the main thing about the customization. What we can give is customization. And the purpose of this thing is like understanding how it works. It's not only like ChatGPT or the Midjourney code to do this type of things. We can also do this thing, right? And we can also achieve that result of Midjourney. The limit which we have is like processing power and data set.
Yes, exactly.
And if open source community come together, we can generate that thing also. Like if open source community is there, then we can get processes, images, and data sets also.
Yes.
That's a very good thing for open source. So those few things, yeah. Yes.
You are passing the token into the generating image, right?
Yes.
So how can you identify like someone is if you are passing the 1,000 tokens into generating image, how can you identify that image is capable to generate within this token? And one more thing is that how many number of images you are generating, 10 images, 1000 images, 100 images, and what is the resolution of that image is maximum resolution and minimum resolution, because DALE API
Yes.
is supporting like in 3 dimensions and maximum number of 10 images.
Exactly.
So what is the difference between your platform?
From here, we are currently using Titan GPU, so we are able to generate 1020 and 1028 images because our GPU limits us there. We can't generate more than that. But if we have some better GPU or multiple GPU, we can generate more size also. If we add more GPU, then we can add more size also. It will also increase the time also, because currently what we are doing is latent space. So 1028 also will be divided by 8. Currently we have done it 5 well, so that way. And the token, if you add like more tokens, it will pass the token also. And there is second way also. Like if you train your clip model in a way to combine multiple tokens into single, like there is a Batman. So in other models there will be maybe Bat and Man separate, but in our it is same. So you can use multiple models also to train. And if you have embedding, there is no worry about like only 77 tokens you can add. You can add more tokens also, but you have to merge some tokens and we have to remove some tokens.
Yes.
And you have to train the model for that, which can say, pick like which token to keep and generate some words.
Okay, I have one question.
Yes.
As you earlier mentioned, a picture of mountain that will replicate.
Yes.
So how can we address such issues, like in real world application? Like flowers, like there were multiple flowers
Yes.
of same color, same size. So how can we address such issues?
Yes, the main thing is like it is trained in that way. It is the model which you had seen. It is trained by our company only. We had taken the stable diffusion model and we had added some of our images to train it on those that way.
So does Stable Diffusion provide such a facility, like we can give our custom images and they can
Stable diffusion it provides just your code. You have to write your own code to train and all of those things. And you can find some open source repositories also to do the same thing, like how to train those things and in multiple GPUs, single GPUs, or even in CPUs, but it will be like a very long time.
Great. Any other questions?
Yes.
Sir, when you were seeing the PE model, we are seeing that we were actually adding some noise to the images, just to get a wide range of images and just to get the loss function active. So, how does our model getting to know that what portion of noise should be added to the image or till what extent should that noise?
Yes. So when we start our model, it is based on cost functions only. So at the starting, it will add one noise only. One means maximum noise. But as we go about our steps, so we have added for 100 steps. So in 100 steps, it will be zero noise adding. But in first step, it is adding one noise. In half of the step, it will adding cosines of 100, whatever it is, like a half of the noise or something like that. If we reduce our steps, if we if you want to generate the same image from the 10 steps only, then also it is possible. So what it will do is like in 5th step, it will add less noise. So if you want to see let's get one demo in second slide. So how we can animate. So here you can see 100 steps. So after each step you can see some noise is added and it is generating its SAP or overall SAP. So it is adding some features, it is removing some features. This is after 100 steps. Let's run it for 21 steps. It will also generate the image after 21 steps also. Yeah, it generated. It is very fast for like a 21 steps. But here we can see very less note is added at the end to get our picture clear result for us.
The more iteration, the more clear picture. Right?
Yeah, more iteration, more clear picture.
Can we reduce the time, like doing something else?
Yes, we can reduce time by two things. Like currently we are using VI or divided by 8. We can divide it by 16 also. But it will affect little bit like accuracy also. But that is the threshold which we have to fix in AI. Like how much accuracy we want and what is speed. So that's the main balance about AI. Like how much we want to keep both the things. Yes.
Similar to SD, are there any other tools so that we can generate videos and artifacts?
We can generate videos with HD also. But currently we have not like HD is not still progressed in that much. You can see like many videos in Instagram or LinkedIn or that where background is also changing. So we still don't have that much features of like generating realistic videos. But if open source community is there, it will be soon something or some good research we are going to see soon.
So those are quite very interesting questions from the people who initially said that they are working into AI/ML, and we really appreciate your interest in this conversation. If anyone is still left and if they want to question anything, please feel free to ask anything. Otherwise, we can proceed further. How about rest of the people like me who don't know AI/ML? તમને કઈ ક્વેશ્ચન છે? પેલું નોઈઝ એડ કરવા વાળી વાત થઈ હતી, આમાં ક્યાંય કોઈને કઈ બીજા વિચારો આવ્યા હોય? સાહેબ આપણે મોઢું ચોખ્ખું કરવા માટે એકદમ પેલી કાળી કાળી ક્રીમ લગાડી દઈ તો એ ચોખ્ખું થઈ જાય એકદમ, આના જેવું કઈ નથી ને. Okay, so Hiren, thank you very much. It was quite very interesting and I would say a little complicated session. But guys, again, I will like to give you this understanding. This is AI. If you are putting your step inside that, you have to deal with such difficult things and you have to work on such harder things as well. And this is the beauty of AI, and that's why it is growing slowly in all the fields. It is not rapidly moving further, right? But again, as promised, few of these guys also asked, and I means one conversation stuck on my mind that if something is there already, then why are we doing that? So again, at the end of the second session, there is something exciting coming from our end, and this is the rule of universe. Like if someone is doing something, some other people are doing it to make it better, not just to copy it, right? So this kind of betterment you will see at the end of the second session as well. But before that, I have few questions. We have got quiz. I have around 10 questions which I would like to ask, and I think few of them are literally very easy, and those who are not following AI/ML too much, they can also answer equally. We have got a small thing for those who will answer them. Guys, please keep it. Okay, slide next. We'll start with our first question. Okay, some of the rules I will say first. Those who know the answer, they have to raise hand. Then I will ask them to answer. If the answer will be wrong, we'll pass it to the another person. None of our team members have seen these questions, so they can also answer, but wait for others to answer first, right? I'm telling this for WebOccult guys. Okay, yes. First question is, which computer scientist proposed the concept of Turing test? Yes, first I got from there. Sorry? Alan Turing, that's the perfect answer. Yes, and as I talked about knowledge, here we have got 10 questions which will definitely increase your knowledge. So the first question was like, which computer scientist proposed the concept of Turing test? That was Alan Turing. Next. What does K stand for in K-mean algorithm? Anyone? What does K stand for in K-mean algorithm? Anyone? Yes.
Number of cluster.
Exactly. Perfect answer. Give him a chocolate, please. What's your name?
Hiran Patel.
Dhiren Patel. Yes, that's correct. Absolutely. Third question. RNNs stand for yes, ma'am.
Recurrent neural networks.
Sorry.
Recurrent neural network.
That's again a perfect answer. What's your name?
Suruchi.
Huh?
Suruchi.
Suruchi.
Suruchi, ma'am. Okay. Thank you. Fourth question. What is the formula of Euclidean distance between 2 points? Euclidean distance between 2 points.
I think this is
when you will get to know the answer, you will all realize that yes, I have gone through this in my childhood somewhere. So the answer is easy, but to know this answer is a bit difficult thing. None is there from other people, so I would like to invite WebOccult team or IT First Solution team to answer. Anyone?
Distance between 2 points.
Euclidean distance.
Okay, first it was by Aditya, so I will give him an opportunity. Yes, Aditya.
So if we have 2 points x1, y1, x2, y2, then we do x2 minus x1, the x dimension, whole square, plus y2 minus y1 to the whole square, and then square root.
That's perfect answer. Okay, here beside me I have got Keval, who was also knowing the answer. Appreciate Keval. He's doing quite nice things by writing the spelling of dinosaur or kind of thing. Very good. Common technique used to find the distance between two embeddings is called as. Hiran has mentioned this during his session as well, yes? Cosine, exactly. Perfect. Give him another one. WebOccult last, not first, please. Okay, which type of networks are used for stock price predictions? I think a lot of people would be doing this. Wait. Yes, which type of networks are used for stock prediction? Stock wada manso. You should have this knowledge. Yes, sir. Huh? No. क्या? Sorry?
Linear regression with
No.
cognitive.
Yes.
LSTM.
Huh?
LSTM.
Yes, right.
Yeah, it is based on
Okay, perfect. Nice answer. Another one for him. Looks like he is winning a lot today. Okay, next question is related to LSTM again. Which is the activation function used inside LSTM as forget cat? Few WebOccult people are also struggling their heads. Yes, it's a top secret. These questions are top secret. Yes, anyone from WebOccult as well?
I think it's 10H.
No.
Not 10H.
Sigmoid, that is correct. Keval is right. Guys, to your knowledge, he is only seeing this. He cannot see anything further. Give him a chocolate, please. Keval, good answer. Okay, now few interesting questions are coming that might be helpful to you if you will ever be placed in KBC in the future. Which AI system defeated world chess champion Garry Kasparov in 1997? Which AI system defeated world chess champion Garry Kasparov in 1997? Yes?
Deep blue.
Perfect answer, sir. IBM's Deep Blue. Very good. Sir, what's your name? Huh? Jay, sir. Very good, sir. Okay, next question, ninth one. Which 2016 AI system defeated one of the world's best Go players, Lee Sedol? Anyone? which 2016 AI system defeated one of the world's best Go player, Lee Sedol? Anyone? No? Anyone would like to try with any answers? There is a hint, like the answer has a word which is there in this sentence. Go something, yes, you are close here.
Go system.
Okay, let's give chocolate to me, it's AlphaGo. Okay, 10th question. Keep the chocolate with you. I have a bonus question as well coming as 11th one, so if anyone will be able to answer, we'll give it to them. Who is known as godfather of modern AI? Godfather of modern. No. Good attempt.
But not modern.
He just visited Wimbledon yesterday or the day before yesterday. Yes. Oh, perfect answer. Geoffrey Hilton. He is about 70 years of age and he has done tremendous things. Like I heard a story that for around 30 years there were no progress in AI ML, and with one solution that he provided, it again began and it boomed. So that's why he is known as the godfather of modern AI. Okay, last bonus question. The question is, which company first organized AI Appreciation Day in India? Yes, everyone can give an answer. WebOccult with IT Path Solutions. A big round of applause for everyone. Nice. So that was quiz part. Now we would like to invite our second speaker, Mr. Jaideep Petadia. He will discuss about insights of computer vision. So let's hear what computer vision means to the world, means to him, and let's get some good knowledge. Thank you.
Good morning, everyone.
Morning.
Okay, so my name is Jaideep and I'm working as a tech lead in WebOccult Technologies. Our today's topic is insights of computer vision, how computer vision is working, what is computer vision, like that. Okay, so what we will see in today's session, like what is computer vision and what are the wide ranges of applications of computer vision, and what are the core concepts and techniques to use computer vision. Another thing is how we can understand the image better and how model can interpret the image better. Okay, so these are the main things that we will cover today. Okay, so first question to you guys, like how many of you think like AI is the future? Can you please raise the hand? Okay, so most of things like AI is the future, right? So how AI is the future? Like we are using AI at every step in our day-to-day life. Okay, starting from autonomous vehicles to robotics, or you can say surveillance and security, or enabling the smart cities with traffic management and waste management. Like there are many more applications of computer vision that we are using in our day-to-day life. Okay, so one question to you guys, like which animal is this? It looks like zebra, right? But it is actually a cow. right? Sometimes it is difficult to identify with the human eye or machine also that what is the object, right? So with deep learning neural network, with advancement and larger data set of diversified images, we can improve these things to identify the correct object. There may be limitations with occlusions and everything, but we can improve that thing. Another question. Which vehicle is this? Anybody?
Loading vehicle.
Sorry?
Loading vehicle.
Okay. Our first impression will be it is car, right? But it is not a car, it is a heavy vehicle, like loading vehicle. Okay. So if we see some part of the image, then our model will identify like as a car if we have a given data set like that. So what we can improve here, we can add tracking and we can say like if it is moving and we can detect that car or truck for multiple frames, then we can confirm what is the object, right? That will help here to identify the correct object, not in the single frame, but with the multiple frames. Okay, so let's start with what is computer vision. So basically, computer vision is when you define or derive anything from image and put some action or recommendation on the same, it is computer vision. For example, I have a selfie of mine. So what I can see in the selfie, like there is a person or human in it, right? So it may be good information from the image, right? Okay, another thing I can get, who is it, right? Then I can say it is me. That is another information. So basically, in layman terms, what we derive from the image, it is a computer vision to use in several ways. Okay, so from where it started, like what is the evolution of computer vision? Okay, in 1966, the first camera was attached to computer. Okay, and in 1970s to 99s, it is not the first time that AI is booming right now. This is the second time. There was a boom in 70s to 90s. Right? But there were limitations at that time, like computational power and many other things. So because of that, it was not moving rapidly from 70s to 20s. So after that, it started there. So in 70s, the few image processing techniques were found. Okay, in 80s, safe inference and contour models was developed. In 90s, there were camera calibration, 3D reconstruction, and image segmentation work was started. Okay. In 2000s, autonomous vehicles and face recognition was started. In 2010s, deep neural networks, CNNs, and object recognition was started. And right now, the world is working on deep learning, real-time applications, edge computing. So this is the evolution of computer vision. Okay. What are the core concepts and techniques, we can say, of the computer vision? So we will start with the data collection. So at the end, after giving some input, we need some result, right? So our input will be data. Sorry, our input will be image, but we will start our model training with the data collection. Okay, for data collection, what things you have to take care about, like, or you have to knowledge for the pixels, for the color space, like RGB, HSV, and grayscale. Okay, and what are the resolutions and what image formats are we using? So we have to take care about that. Then we have to prepare the data. Like we don't have to prepare the same type of data. The data should be diversified for training the model. The second thing is pre-processing. So the data you have prepared or collected, that maybe not exactly the model wants, right? So to make it quality data, quality image, and suitable image for the model, you have to pre-process the image. Like it includes blurring the image, sharpening the image, noise reduction, and all those type of techniques. That is pre-processing. Third thing is feature extraction. So we have to identify the features from the image, right? So if I want to use the face detection model, so there should be some 2 eyes, 1 nose, lips, that type of thing. That are the features of the image that we have to define, right? So there are 2 types of feature extraction. First is manual feature extraction, and second is deep learning feature extraction. Before, researchers were doing manual feature extractions, like defining the patterns or edges or corners. But now with the help of deep learning networks, we don't have to do that. They will identify the patterns at their own, okay? And it will give us the results by our data. The next step is model training. So after collecting the data and labeling the data, we will give it to the model for training with our with few parameters. And so this is the main part, like how we are or which model we are using for training, right? Okay. So after model training, when once the model is trained, we have to evaluate and validate the model. So for the data, we have already separate the data like test data and the trained data, right? So for model training, we will use the trained data, and some of the data we have kept for testing. Like so, once model is trained, we will use that test data to test the model, like how it is performing or how much it is accurate. Okay. The next part is deployment and inference. So once all of these things are done, like model is trained, it is evaluated, it is working good, we have to deploy it somewhere to make it in production, right? And start inferencing, so we can use that model in whatever the requirements are like. Okay. The next thing is continuous improvement. Okay. Now we have a model ready for our trained data and test data. So it is working for that images. But when there are new images coming, which data is unseen for the model, right? That may problematic for the model or give inaccurate results. So if we found that maybe there are possibility like we have to retrain the model with the new data or fine tune the parameters of the model to get the correct accuracy. So we have to do a continuously improvement if there is necessary. Right? So these are the core concept or techniques of computer vision. Applications of computer vision. I have just listed down few of them, but there are many applications of the computer vision. Okay, let's start with the autonomous vehicles. Okay, where the computer vision is used in autonomous vehicles. So, as you all know, like computer vision will help to identify the surroundings of the car or vehicle, right? Also, it will detect the lane, which lane I have to drive. Okay, it will also monitor the traffic lightings. So where I have to stop, where I have to stop, like that things. Also, it will detect the pedestrian walking on the street, so it will stop there. So those kind of computer vision techniques will help us in autonomous vehicles. Second thing is surveillance and security. For the security, we can use like face detection or face identifier for the computer vision. Like we can give real-time alerts to the users if there is an unauthorized person comes into the picture, like that one. Okay. Medical imaging. In medical imaging, we can generate. There is also a term like digital pathology, right? So which identify the images or cells and generates the report based on that. And also it identifies tumor detection or any disease detection based on the images. That is helping in the medical industry. Okay, retail and e-commerce. Okay, in retail there are counting of footfalls, and if you have seen the rack and there are products, and if you see any missing product, that it will identify you. You don't have to worry about the staff like checking every product each time, right? Those kind of things can be done with computer vision. Also it visual search, you may have seen like in Amazon you can search visually, or Google you can search visually. That can be done with computer vision, like which product is that and I have to search, I'll be searching for that. Okay, next is industrial automation. From manufacturing line we can use computer vision to identify defective products. Like in the pipeline, if I see some defective products, it will automatically remove that product, which will improve the quality control, and it will also increase the efficiency and productivity of the company. Right? And also it can handle like tracking of the product in the pipeline. Yes. Another thing is transportation. So as I said, it can be used in traffic control, those type of things. AR VR, it helps in AR VR, like it enriching the user experience with the computer vision. Like if I'm seeing, if I want to buy a table, for example in Amazon, now they are giving like how the table will look in your room or drawing room, right? So that thing is already there in Amazon. Robotics. You may have seen some robots are delivering the parcels to people. So they also use the computer vision to identify the surroundings and all. Agriculture and farming. In agriculture and farming, you can see what type of crop is there, or there are also drones who throw the pesticides or the crop, right? So they know where I have to throw the pesticides and all. Also, you can know like how much the crop is mature, like how can I harvest that? When I can harvest that crop with help of computer vision. If I have images of that crop, I can say like what is the maturity or age of the crop from the image, if I have data set for that. Right? Another thing is document analysis. Okay. So the most important part is the OCR. Like we can use the OCR for identifying the document or classify the document. Also it can be used in handwriting identification. So those type of applications can be used with computer vision in document analysis. The next thing is sports analytics. So you may have seen some real videos while players' pose is detected, or how it is bowling or batting, right? So what it collects like the data of any famous sportsman, and based on that it identifies how he is doing his performance better. Right? So it uses in coaching and the performance analytics and everywhere. Okay. Okay. So here are few images that I am talking about of applications. First thing is a rack of mall or any shopping center. Right? So we can identify that how many products are missing in the rack. Right? So staff don't have to check every time like which products are missing, and they can fill just by the alert or report. Right? Second thing is plant disease identification. So you may have seen some applications of that, like we have to upload a picture and it will identify like what disease is in our plant. Right? So this is the second type of application. Third thing is footfall in any mall. So it will help mall to identify what is the footfall of our mall and how can we improve that. Right? The fourth one is about the crop identification, which crop is there, how mature is that, when I have to harvest that crop, like that one. Okay. Here the first one is for surveillance, like employees are wearing the helmets, gloves, shoes or PPE kit, like that. So if not, then it can just raise an alert for security purposes. Second thing is blood cell identification. So yeah. The third thing is you can find any missing thing in the product. If for example here is a strip of the pills, then I can see like there is a missing pill. So I have to count as a defective product and just remove that product from the lane. Right? So it can help to improve the quality or efficiency of the industry. The fourth one is crack and fault detection in the road. Okay. Yes, next. Okay, so we have seen some applications of computer vision and how it is working, right? So what are the limitations or challenges we can see in the applications? So first thing is we might have some limited data and not too much of data. So when some unseen data comes, it will get us the inaccurate results. Right? First thing is that. Second is ambiguity and interpretation. Like we might have data of winter, right? And in summer, if we are seeing the product, that is different. Right? So those conditions will affect these things. So we have put data for all the like this type of conditions. Third one is handling real world variations. So lightning conditions, weather, viewpoints, and object variations. So it all can affect to the image processing, right? Yes. The fourth one is limited understanding of context. So while we process any image or identify any object in the image, the context is necessary. Like what is the context of that image? It should be same as like human centric. Computational complexity. For doing all this model training and inferencing, it takes a lot of computational power, which few companies can't afford right now, right, to use the AI. So that is the main challenge, how we can, in less computing, we can give the better results for the computer vision. Ethical and privacy concerns. Okay, so you may have seen some videos of any celebrity, fake videos, you can say. So there is a challenge also right now, like the fake things can happen with AI, deep fake. Yes, and privacy concerns. So if you have put a camera and it is identifying or taking your picture, that may be a privacy concern from some person, right? Recently in Italy, they just banned the face recognition model, right? So it is also in limitation and challenges. Yes, explainability and trust. When we are doing any medical app or something like that, there should be a trust problem. Like for medical, what the thing is, it should be 100% accurate, right? Because it is a question of person's life, right? So there are issues of trust and explainability. Next. Okay. So what are the future trends of computer vision? First one is deep learning advancement, like deep learning is growing more and more in these days. And second thing is generative models. It is trend right now, as we have seen. Okay? The third thing is 3D vision and reconstruction, then cross model learning. Okay, so if I am using an application with various features, it identifies this, and many things, right? So maybe I have to use different models for the same, right? So that is also in trend, like how can I achieve this while combining all the models at once, right? Okay. Edge computing and real-time applications. That is not possible. We keep everything on cloud computing. Right? It will affect the latency and, like, for example, I am seeing the live feed. Right? I cannot give the data to cloud computing at every frame. Right? For that, I have to use the edge computing. I have to put a device beside the camera, right, which computes the frame and gives us the data on cloud. So it is in trend, like edge computing, like we can inference the camera frames. Yeah. Yes. The same thing is privacy and ethical considerations that the world is working on. Like how can we remove that part or give a better result to community without privacy concerns and ethical things. Okay. What type of resources or tools we can use to start these things with computer vision? Right. The first is OpenCV, widely used open source platform that is built, that is available in C++, Python, and Java, which gives us the whole set of functions that we want to use for image processing and all. Right. TensorFlow and PyTorch. TensorFlow is it is a machine learning library, open source library developed by Google that gives us the object detection API that we can use with pre-trained models and gives us the object detection or image classifications, those type of things. Right. Cafe is for the same, and it is known for its efficiency. Okay. PyTorch, which is same like it is a deep learning library which we can use with pre-trained models, and it will give us object detection, object identification, and image segmentation and everything. MATLAB, it is a user-friendly interface for identify the metrics or the result of image analysis that we can use in MATLAB. NVIDIA CUDA toolkit. So if there is a need of GPU computational power in our model, then we can use the NVIDIA toolkit for the same. Okay, last things are online courses and tutorials. So we can start, we can pick any tutorial from Coursera or Udemy like that for computer vision from scratch to the beginner level. Like we can build some models, right, to learning. Also, if we want to see like what is the exact math or what they are doing, so we can see their research papers, right? Yes. Next. Okay, that's it from my side. So, do you have any questions? If you have any questions, you can please ask.
Okay guys, so Jaideep in his simple language has explained us about the power of computer vision, like in which industries it is being used and what could be the scope of computer vision going further. So again, if I come to that topic, whether it is good or bad, he has explained it very beautifully. there are benefits, there are hundreds of benefits, and there are some concerns as well, which we all might face going further. But if I talk about myself, I would say AI is simply saving our time, right? If we use it in correct way, then it can definitely be helpful in a lot many ways. So things which are good for us, we should definitely take the maximum out of it. And those who are not good or ethically not good, then we can skip using those things as well. But our mobile phone, as we know, it detects a lot of things about us and we are not doing anything. Google, for example, if we are using Google Gmail or Google Maps, it detects everything wherever we go, wherever we go in any time, any country, anywhere. So things are like this. Because of it, we are getting good results as well. And this is how computer vision is expanding. So we hope you have got to know about computer vision at basic level, like what actually it is and how it is being used in the world. Still, if some of you have any questions, then these two guys are here to answer for anything, and we can start this. Anyone? Okay, thank you, Jaideep, for your time. It was nice talking. Yes, okay, so both the sessions are done. Now, as I talked about one announcement that we wanted to do, I would like to invite my colleague Hiral to come here and get us through that. Thank you.
Thank you, sir. Good afternoon, everyone. Good afternoon, everyone.
Good afternoon.
Okay, great. Today we are celebrating AI Appreciation Day, right? So we designed to celebrate this day in two ways. First was knowledge sharing that we already completed. The second part is solution sharing. When we started this session, in first slide, sir displayed the rules of the set of rules, and the first rule was don't make noise. That rule was for first part, not my part. Okay, so everyone can add some noise as we just get to know from Hiran that noise is good sometimes, right? So now let's make some noise. Good afternoon, everyone. No worries. I can make noise without. No. Is it audible? Yes. Fine. So, why we are together today? To appreciate AI. What is AI? What is artificial intelligence? That I know. What is AI? For me, for you, for today, AI is not just a concept or just a definition. For today, AI is a bridge which connects all the people together on this floor, right? I know you from last 2 hours. You know me from. You still don't know me. You know my face. You show me just because of AI. AI is the bridge which connects all us together, right? Hardik sir asked one question in the starting of the things that how many people are working in AI? Few people were there who are working in AI, right? But you are here just because you have some curiosity or you have some તમારી પાસે એવું કંઈક છે કે તમને જાણવું છે કે AI શું છે, right? So I can say all the people on this floor are either directly or indirectly connected with AI. Right? So today we are announcing one very big thing. This is the very big day for us, and I am very privileged to get this opportunity to announce these things. We are going to launch our one big application which is built in AI. Okay? So one says that any big steps, it starts from any big thing, any big achievement. It starts from one strong but small step. So today we are not going to launch a Chandrayaan, but we are going to launch our first small beta version of our applications, right? So what is it's all about? This application is based on facial recognition, right? Everyone knows that there is a many model, there is a many technology available in facial recognition, but we have our facial recognition model inbuilt in our company, and we are using that model since 2 years. With the time, with the experience, with the experiment, we are updating that model, and now we can proudly say that we have the state-of-art facial recognition model. Some faces might, I remember that I saw some people in Larapon as well. We launched that model in a older version in Larapon also. So now we have that facial recognition model with best version. So what solution we are going to provide? We have provided two solutions in one application. For example, let's say example of this meter. You have seen that many 3-4 photographers is taking photos from last 1 or 2 hours, right? What happens in all meetup? તમે ક્યાંય બી કોઈ બી મીટઅપમાં જાઓ તો શું થાય કે ફોટોગ્રાફર્સ ફોટોસ લેતા હોય એમાંથી 5 થી 6 ફોટોસ જે બેસ્ટ છે એ લિંકિંગ ઉપર પોસ્ટ થાય. મોસ્ટલી ઇવેન્ટ સેટરડે ઓર સન્ડે હોય, લિંકિંગ ઉપર પોસ્ટ મંડે થાય અથવા ટ્યુઝડે થાય જ્યારે એ લોકો પાસે ફોટોસ આવે. We are providing the solution that after the 10 minutes you will get all photographs. With bifurcation. I have all photographs, but I have 10 photographs in which I am there. Right? By facial recognition system, you will get that photos immediately. This is the first solution. Second solution is if you are going in the trip, right? In the mostly young people are here, right? So in trip, what happens? I am going, my friends is there, my 2 friends are there. We are 3 people, but with us, મારા ફ્રેન્ડ્સ ના બીજા 2 ફ્રેન્ડ હોય, એના બીજા 2 ફ્રેન્ડ હોય, અને એનો હજી 1 ફ્રેન્ડ હોય. એ મને ટ્રીપમાં જોઈને ખબર પડે કે ભાઈ ઓકે આ આવી રહ્યો છે, એનું નામ મને ટ્રીપ પહેલા ના આવડે. સો એવા 10-12 લોકો મ્યુચ્યુઅલ ફ્રેન્ડ છે, એ લોકો ટ્રીપમાં જાય, રાઈટ? હાઉ કેન દે શેર ફોટોસ? એ લોકો શું કરે? આઈધર વોટ્સએપ નંબર શેર કરે, વોટ્સએપમાં ક્વોલિટી ખરાબ થાય, ઓર એક માણસ પાસે ગૂગલ ડ્રાઈવ હોય, એમાં અપડેટ કરી દે, એની લિમિટ આવી જાય. There is a n number of solutions, right? Our solution is not better, not worse. I am not comparing with any other solutions, but we are providing one more solution to share the photographs when you are going in trip. You can just click and upload photographs, right? Instantly, you get bifurcate, you get your photographs in a separate folder and all photographs separate folder. So you just don't need to download all the photos. Sometimes what happens that તમે 15 લોકો ગયા એમાં 2 લોકો છે એને ફોટોગ્રાફનો બહુ શોખ છે, તો એ 25, 30, 50 ફોટોસ પાડશે. મને શોખ નથી, રાઈટ? તો મારા ગણીને 5 ફોટો છે. એ 5 ફોટો મને જોઈએ એના માટે હું સાઈટ ડાઉનલોડ કરીશ, પછી સોરીશ, પછી જેને અપલોડ કર્યા હશે એને હું મનમાં થોડાક સારા શબ્દોય કહીશ કે આટલા બધા હોય. સો આ બધી નાની નાની વસ્તુને ઓવરકમ કરવા માટે આ એપ્લિકેશન we are providing the solution for these two things. In our application there is a many things we have. ઘણું બધું છે, ઘણું બધું શેર કરવું છે, આપવું છે, but right now this is a beta version અને એમાં બહુ લિમિટેડ ફંક્શનાલિટી અત્યારે અમે પ્રોવાઈડ કરી છે, રાઈટ? સો હું તમને એપ્લિકેશન અને બધું આપશું, but before few days we were thinking that આપણે એપ્લિકેશન બનાવી છે, આપણી પાસે આ મોડલ છે, આપણી પાસે બધું છે, but what is our target audience? કોને આપણે ડેડિકેટ કરી શકીએ અથવા તો આ કોના માટે છે? What is the end goal for us? And અમે લોકો બધા ભેગા થયા, brainstorming કર્યું, and we conclude at a very good thought that today we are here with support of many people. We WebOccult family are not based on one person or not 2 person. So this app is dedicated to all the person કે જેને લઈને આજે અમે લોકો અહીંયા છીએ. Second, the community. આપણે પહેલા સેશનમાં વાત કરી, AI is basically based on community. જો community strong છે, બધા people એક સાથે છે, we can achieve anything. For example, મારે આજે કોઈ મોડેલ ટ્રેન કરવા 1000 ઇમેજ જોઈએ છે, it is very difficult for me. But અગર હું GitHubમાં એક રેપો બનાવી કમ્યુનિટીને હેલ્પ માંગીશ, બધા 10-10 ઇમેજ અપલોડ કરશે, મને જોઈએ એવી 1000 ઇમેજ મળી જશે, right? So for AI, community is a must. So we are going to dedicate this application to the people who supports us till the day, the community કે જેના બેઝ પર અમારો કોન્ફિડન્સ છે, જેના બેઝ પર અમને અત્યાર સુધી કમ્યુનિટીએ જે આપ્યું છે, and the nation. So today we are going to deliver this app, we are going to dedicate this app we are giving back to the nation, we are giving back to the community, and we are giving back to the people. They are support by yourself, right? So we are in 5 minutes, I can say in 2 minutes, we are going to launch our application. But right now we don't have any firecrackers or we don't have any fascinating things, right? કે જેનાથી આપણે celebrate કરી શકીએ, but we will celebrate in another way. As I told, we અત્યારે ચાલે બી છે આઝાદી કા અમૃત મહોત્સવ, ये year भी चल रहा है. So what we are doing, I remember one thing that मंजिल उन्हीं को मिलती है जिनके सपनों में जाना. Okay, वाह वाह करो, ताली बजाओ, you should. मंजिल उन्हीं को मिलती है जिनके सपनों में जान होती है. सिर्फ पंखों से कुछ नहीं होता, हौसलों से उड़ाना. When we are going to take this done, I request everyone to stand up at your place and join me in national anthem. We will launch this app with national anthem.
भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा. तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाए तव जय गाथा. जन गण मंगलदायक जय हे भारत भाग्य विधाता. जय हे जय हे जय हे जय 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 हे.
भारत माता की
जय.
वंदे
मातरम.
Okay, so the name of this solution is memorylens.ai. This is the basically AI powered photo gallery. First of all, how many we have Android users? Just like me, proud Android. I am proud Android. Okay, you can install the application beta version right now. I have something for iOS user as well, but Android is first. You can scan this QR code. If you are not able to scan the QR code, you can ask for it.
हेलो हेलो
इसको ये करना पड़ेगा, इसको स्केच करने को
This app is yet not added on Play Store, so it might show some message in your mobile that from unknown source, so you can install anyway.
भूमिका सुबह सुबह यहाँ पे भी लगा थे ना, यहाँ पे ही डायरेक्ट लगा दे।
हाँ वैसे ही होगा तुम
आगे 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 हिला ना मत,
आगे होगा
आगे आगे
मेरे को लाइव इधर दिख रहा है, ये लौंडा लाइव चला रहा है, आप लाइव नहीं वाचिंग कितना दो वाचिंग एक दो उसका मैं कुछ नहीं कर सकता, दैट आई कांट डू एनीथिंग, मेरा काम था बनाना सब
Okay, let me tell you next step. You can click on join group. It will ask for 6-digit code. Code is there on the slide. So you can just join the existing group. After that, you can create a group. But first of all, please join the group and enjoy your photographs. Then explore the application. The code is capital E, capital D, 0, capital O, capital B, small x.
Yeah, nice. Oh, they captured me. See?
Okay, if you already joined the group, you can see the two tabs in that group. There will be the My Photos and All Photos. All Photos having all the photographs of this event, and the My Photos and your photograph. It will take might 1 or 2 seconds or sometimes to get your photographs. Right?
So once you have registered your face, it will detect your face from all the photos which are there, and it will display all those photos in a separate tab. So you don't need to search for your photos elsewhere. This is the main use of this.
Yeah, will detect
Yeah.
Okay, guys. At 12:30, only photos are not enough, right? So there is some other things also waiting for us. Before that, let me share one thing. Now you can create any group. There is, if you create any group, then it will give you the two options: that small private group and big public group. If you create big public group, that simply means that only admin can upload the photograph, just like I created that group and you entered the photograph. If you choose small private group, that means that all members can upload the photograph. If you are 7-8 people and all are friends, then allow all to upload the photograph, right? So you can explore the app after that, afterwards. So right now, enjoy your photographs, and I will. I will hand over this session to Alex.
Okay, guys. Thank you very much again for your time coming for this event, enjoying what we have delivered. I would like to end my speech by sharing again few important notes here. First of all, a big round of applause for those guys who have contributed a lot in the development of this product which we have launched. All of them are directly or indirectly who have been involved in this project management, developers or managers. They are all available here. Second, a big round of applause for all 70-80 people who have gathered today for this event. Third one is for all the volunteers from both the companies, WebOccult and IT Fast Solutions. They were working days and nights to make this possible, to give you the best knowledge, to give you the best facilities in all terms. So a big round of applause for them. We as WebOccult Technologies would like to thank our deep thank to IT Pass Solutions, especially Nirav sir and his team for providing us such a facilities. And means one time when Ruchi spoke to them, he instantly said, yes, we are ready, we'll do that. So all these facilities for providing these and give us this platform, we are very much thankful to IT Pass Solutions and their founders. Thank you. Okay.
Okay, so session is done. I would like to take a group photo of every one of us, and I think this place is more suitable for the photo. Though few people can sit, few people can stand. We'll take a photo. Once the photo session is done, people can go there in the cafeteria. They can have snacks. And then they can also, there is one goodie we are providing to all of them, so they can get that as well. And plus I would like to thank our online viewers who are constantly watching this YouTube session online. So thank you very much. Again, I am repeating, a photo we need here, and some goodies are there which we want to give you to remember this day forever. And then you can have snacks, you can do networking, and we can leave. Thank you very much. It was nice meeting you all here, and have a nice day. Bye bye.